5, 4, 3, 2, 1.
Inductor is an electric component that has the characteristic against the change of the current. It made by winding the wave conductor around the ferromagnetic material. There are two types of inductor. Fixed-type inductors is a classification of inductors according to their structure. It's commonly used in inductive devices. It's also called as a fixed coil. It can be a coil with a single layer, multiple layer, honeycomb type, or magnetic core. The other type of inductor is variable type. The most common type of variable inductor today is one with a movable ferrite magnetic core, which can be slid or screwed in or out of the coil. The units for inductor is Henry, while the symbol is L. Inductor is a spiral structure coil of wires that can create magnetic field when current passes through it. Increase the current in a coil will create a changing in magnetic field that will generate an electromotive force, EMF, in the coil. Inductor can be said as very interesting device. As we can see, when we're simply connected DC power supply across it, it acts as a magnet. A steady current through a coil causes a steady magnetic field and cuts the wire. This field stores energy, which produces a voltage, which tends to oppose changes in current. Let's take a logical look of the physics behind the inductors. A current-carrying conductor produces a magnetic field around it. Now, let's take a look to a very interesting experiment. If we bend the wire, the magnetic field lines interact with each other and produce an interesting magnetic field pattern. As we can see, look at the pattern of magnetic field carefully. This magnetic field pattern is similar to a permanent magnet, which is wire currents carrying act like a permanent magnet. The increasing of the number of loops can increase the magnetic flux. Now, let's talk about the effect of inductor as the electrical device in the electrical circuit. Firstly, it can smooth the wave ripples in the DC circuit. The use of inductor also can improve the transmission characteristics of waves in the telephone line. Now, let's talk about inductance. Inductance is a characteristic of the inductor that oppose any changes in current through it. There also have the type of inductance. Self-inductor, symbol as L, is occur when a current flow in the coil causing the changing of flux in the winding. The electromotive force, EMF, produced is opposite direction with the direction of applied voltage, while mutual inductance, symbol as M, is occur when a current flow in the first loop. Flux will be produced in the first coil. The continuous current causes flux flow to the next coil, and then generate EMF in the second coil. EMF produced in second coil will cut the conductor and the voltage in second loop. Now, let's continue to circuit analysis and the example of the calculation for inductor. Same as resistor and capacitor circuits. Inductor circuit are slow consist of series and parallel circuit. The series circuit is when we connect the inductor as series such as L1, L2, L3 and L4. To get the total inductance for those series inductor, we need to plus all the value of inductor. In this case, LT is equal to L1 plus L2 plus L3. Then we get the answer as total inductance. As for parallel circuit, the total inductance is given by The formula 1 over LT is equal to 1 over L1 plus 1 over L2 plus 1 over L3. Now, let's take a look at the inductance, reactance and energy in inductor. Inductance reactance is the opposition of current flow. When alternating current, AC, is changing continuously, which is turn produced continuous opposed induces EMF. The formula for inductance reactance is XL equal to pi F L. Hence the unit is ohm. As we can see the example, given the value of inductor is 0.2 Henry, AC voltage 200 volt and frequency is 50 Hz, energy in inductor was produced an electric current flowing in the inductor. The energy was stored in the magnetic field of inductor. The value of energy in an inductor is given by the formula as E equal to 1 over 2 multiplied by Li square. Here is the exercise for the inductor. The circuit is called as series parallel circuit. To solve this type of problem, we need to simplify the circuit into the simple circuit. Firstly, we need to identify the series and parallel inductor. We can see that L3 and L4 is parallel. It can be simplified to become L3, 4, while L1 and L3 for become series and simplified to L1, 3, 4. Then L to become parallel to L1, 34 and simplified to LT. That's how we solve this type of question step by step. Be careful to put the right value and use your calculator properly to avoid any mistake during calculation.